Okay, welcome to part 2 of Introduction to Analysis of Variance. We are going to start with estimating the population variance. As I ended the last video, I said with analysis of variance, you are required to estimate two different types of variance for your population. The two different types of variance that you must estimate are called within-group variance and between-group variance. Within-group variance is just as it says. It is the variance due to chance factors within each sample. So let's say you have three groups, group 1, group 2, and group 3. As I stated in class today, just by drawing the people that you have and randomly assigning them to different groups, the groups may end up being very different from each other. Their means, because of random assignment, should be close to each other. But if you have all the top students who just by chance get in the first group, then those students' mean is going to be very different from the other two group means that are more equally distributed. So that's what we mean by within-group variance. Each group, simply based on the makeup of the participants in that group, is going to contribute to their overall mean. And one or two or three of the means may be very different from each other, simply by the nature of the members you have in the group. Between-group variance is a little bit different. This variance is due to chance factors within each sample group, like I just talked about, the luck of the draw, the participants that you get in each group. But it's also due to your different levels of the IV. You will also hear this called treatment or treatment effect. Depending on the level of the independent variable that a particular group gets, if one level is very different from the other levels, then you should see this in the end when you measure the dependent variable. So when we are calculating our final statistics, we actually take into consideration that each group has its own unique differences to begin with. Fine, okay, so we're going to account for that. In other words, we're going to take that out of the equation. If this group differs a lot from this group, which differs a little from this group, that's fine. We're going to take that out of the equation by calculating the within-group variance. Then, any difference that's left between the groups should actually be due to between-group variance. That is, whatever the IV level they got caused the dependent variable to respond in a certain way. Within-group variance is not affected by whether the null hypothesis is true. In other words, the null hypothesis really refers to whether or not there is a difference between the groups, not within them, not within each group and its participants, but between the three groups. This variance really is due to chance factors again, just who happens to get put in what group. The between-group variance is influenced by the null hypothesis. In other words, the between-group variance, if the null hypothesis is true, should show no difference between the groups. If the null hypothesis is false, you should then see differences between the groups, and this will be due to your treatment, that is the level of the independent variable that each group received. What this particular figure shows is that if you look at the mean samples from population whose means differ, it's the samples will vary more than the sample means taken from populations whose means are the same. The scores in each sample that you see are shown by particular dots. So again, where you choose to draw the means, in other words, the groups, the people who end up in your group, will influence the similarity between the group means. If you look at the left-hand column, notice that the scores are all pretty much drawn from the same place in the three different populations. And again, if the null hypothesis is that these three populations have a similar mean to begin with, then the means of the three populations will look very similar. In contrast, if your populations do not all have the same mean, which is what the right hand shows, notice the first you draw sample scores from here. In the second population, you draw sample scores from here. And in the third sample population, you draw the sample scores from here. Now, even though you drew the scores similar to where the means are in each population, the populations themselves are so different that when you go to compare the means, the one in the center, that mean is much higher than the other two means, simply because the population is not the same as the population where the other two means were drawn. So again, to recap, when the null hypothesis is true, variance is due only to chance factors within each sample. So if you run your F statistics and you find that you cannot reject the null because it is true, then that means any difference you found between the groups is simply due to the chance factor that each group is different to begin with. However, if the null hypothesis is true, then any variation is due to the chance factors within each sample and the effect of the independent variable, because each group got a different level. So if you find that you can reject the null, what you are saying is that these three groups really do differ. They differ in two ways. Number one, they differ because simply by nature they have different participants in them, and so therefore they have some difference. But the biggest difference is actually due to the level of the independent variable the groups received. If this group received level 1, and this group received level 2, and this group received level 3, if level 3 works better than levels 1 and 2, then you will find that this mean is much different. It's very different, statistically so, than the means for group 1 and group 2. So, the basic logic of an analysis of variance is, again, you have to estimate population variance using your sample scores. There are two different types of variance that you must estimate. You must estimate within group variance and between group variance. You are then going to use the two types of variances you estimated within and between, and you are going to create a ratio. This is called the F ratio. You will then compare your F ratio to a table of F ratios to see whether or not any of the group means differ statistically. And on that, I will move to video 3.